The Unit Circle, A Radius of 1 by Tom Adams. The unit circle, we call it the unit circle because it's a circle that has a radius of 1. We use it in trigonometry because if you take a circle and you put it on the xy plane and let the center of the circle be at the origin, we can form angles by swinging an angle counterclockwise from what we call the terminal side. The tip of that angle will intersect at the circle in such a way that it forms a right angle triangle, where the opposite side and the adjacent side and the hypotenuse are going to help us to determine the values of trigonometric ratios. Essentially, because it's a unit circle or the radius is 1 unit, the hypotenuse will always equal 1. That's a helpful thing when we go to do these trig functions. So just to recap, if I start at the center of a circle that's on the xy plane and I sweep around the unit circle, it will always form a right angle triangle, which will give us an opposite side, an adjacent side, and a hypotenuse. And because the radius of the circle is 1 and the hypotenuse of the right angle triangle is the radius of the circle, then the hypotenuse will always equal 1. What we want to do is use these right angle triangles and compare the trigonometric ratios. For example, sine is equal to the opposite over the hypotenuse. So since the hypotenuse is equal to 1, sine is actually equal to the opposite over 1, or sine of theta is equal to the opposite. If we look at the point where it intersects the circle, we notice that the y-coordinate is actually equal to the length of the opposite side. So in essence, sine of theta is actually equal to y of the point on the circle based on what theta is. As we sweep that around, the y-coordinate will always equal sine of theta because it is equal to the opposite side length. Likewise, for cosine, adjacent over the hypotenuse, cosine equals adjacent. Again, we look and notice that in this case, the x-coordinate is equal to the length of the adjacent side. In other words, cosine of theta on the unit circle will always equal the x value of the circle. So with that in mind, we now have that sine of theta is equal to y and cosine of theta is equal to x for any point on the unit circle. Remembering that tangent is sine of theta over cosine of theta, and that's going to yield sine of theta, which is y, over cosine of theta, which is x. So tangent then would actually be y over x of any point on the circle. Let's do some practical examples of this on the unit circle. When we start at the terminal side of 0 and we move counterclockwise, at the top of the clock is 90 degrees or pi over 2. All the way a straight line across is 180 degrees or pi, and then 270 down at the bottom is also 3 pi over 2. If we sweep and make an angle, in this case an angle of 0, we end up with a point on the line of 1, 0. If we sweep and have an angle of 90 degrees, the coordinate point is 0, 1. 180 degrees is negative 1, 0. 270 degrees is 0, negative 1. And then we end up at 360, and that's right where we started. So sine of 0 is equal to y, but y of 0 is actually 0. Cosine of 0 is equal to 1. Now the 0 is theta, how much we sweep around. Then we simply plug in the x and y values for the appropriate trigonometric functions. Remember that sine of theta and cosine of theta equal y and x. Let's try this again for 90 degrees or pi over 2. Sine of 90 degrees would equal 1 because at 90 degrees the y value is equal to 1. The point on the circle is equal to 1. Cosine of 90 degrees is equal to the x coordinate value, which is 0. And then tangent is y over x, or 1 over 0, which is undefined. If we swing our angle around to 180 degrees, what we'll see is different values, but they're still based on the x and y coordinates. So when we look at the point as we swing theta around 180 degrees, the point is -1, comma 0. X is equal to -1, y is equal to 0. So sine of 80 degrees is equal to 0. Cosine of 180 degrees is equal to -1. Tangent of 180 degrees is 0 over -1, which is equal to 0. Again, if we sweep our angle starting at 0, or what we call the terminal side, and come all the way around 270 degrees, our x and y coordinates are going to give us the values for our trigonometric functions. Sine is equal to y, so sine of 270 degrees should equal -1. Cosine of theta equals x, so cosine of 270 degrees should equal 0. And then tangent is x over y, or I'm sorry, y over x, or 1 over 0, which is undefined. If we sweep around a full 360 degrees, all those values will equal 0 degrees, and then we start over.